the device, not only are they going to be going after the data that's on it, but they also may be looking at the applications that are installed. If you have special custom applications you're deploying internally to your employees, you can try to obfuscate certain information in it, but it's only going to get you so far because the attacker now has the device and they have as much time as they want with it. So I've talked about some of the common issues here. I'd like to move on to platform-specific issues. Let's talk about the Blackberry platform. Just at a high-level view, they've sold about 10 million phones by now, which makes them the largest smartphone vendor in the world. Interestingly enough, their smartphone deployment doesn't exactly line up with the number of applications that are currently available for it. Applications aren't required to be available on RIM's app world, but at last count, there are over 2,000 apps there. Compared to some of the other platforms we'll be talking about later on, that's quite a small number, but certainly with the upcoming release of Blackberry 6.0, I'm sure RIM is looking to change that. Something to keep in mind is Blackberry is primarily a Java ME environment, which is to say that it's kind of like Java except where it's not. Blackberry has specific APIs that they're going to be providing, and we'll be talking about those in the next few slides. So one of the first things you'll be looking at for any kind of application these days is storing some information. The Blackberry provides 3 separate APIs if you have information that you need to persist past the lifetime of your application, past the lifetime of the device being rebooted. Blackberry has a persistent store and runtime store, which is flash-only memory. They implement a JSR75 file connection, which is creating actual files on the device. And with Blackberry 5.0, you have the ability to create SQLite databases. So for persistent store and runtime store, they're both based on key value pairs that are stored globally. This is one of the unique instances where you'll see a blatant violation of the sandbox paradigm. One of the consequences of that is that keys can't be guaranteed to be unique. An application can set whatever key it wants, and another application may try and set the same key. If it exists, there's going to be a collision. If it doesn't, it gets there first, and that can be kind of a problem. So in Blackberry's documentation, they say, well, the polite thing to do is make sure that your keys are predicated based on the package name of the application you're setting, and then tack on whatever unique value you want there. And then you convert that to a long integer and use that as your key. It's a neighborly practice, but it's not very resistant to a determined attacker who can simply iterate over every persistent object that's been stored and get all of their values. Actually, I'm skipping a bit here, so let's rewind a bit. The persistent objects that get stored in the persistent store also take a second level depth to the objects that get stored. So if you define an object as being persistent, any sub-objects that those objects are referring to are also going to get stored. So you should keep in mind for any particular object that you want to save that it's not referring to any other objects that you want to make sure don't get saved. In the case of persistent objects that are completely defined in terms of built-in objects, those objects will actually remain even after the application is removed. In the case you've defined unique objects, those will be removed with your application, otherwise they're going to stay. And finally, in order to make sure that those objects are accessible only by you and not any other application that's on there, you can wrap persistent objects in a controlled access object, which informs the Blackberry that the only applications that are signed with the same key as the one that created this object are the ones who are going to be allowed to read the values or write new values to it. And this is a nice way if you need to share objects between applications. If you have 3 different applications that are signed with the same key, they'll all be able to access these persistently stored objects. Just as a quick note, the runtime store works exactly the same way, except that any object there won't persist past a reboot. You can do controlled access there. You need to be careful of the object inheritance. But unlike the persistent store, once the device is rebooted, all of those objects are gone. So moving on to file connections. File connections are, let's see, how do we introduce this? The JSR75 is a platform-independent specification for how Java ME environments should support the use of PIM data and file data. So because Java environment doesn't support using the standard file I/O, you have this concept of a file connection, which is a connection to the file system, but not necessarily to the specific file that you're interested in. So you need to make sure that once you have a connection established, that you don't just start going and doing whatever you plan to do. Make sure that the file actually exists before you start operations. File connections support standard permissions for reading, writing, and read writing. But the caveat there is that enforcement of those permissions is dependent on the security schema that's implemented on the device. Different BlackBerry devices may consider permissions to be enforceable or not. And so that's something to keep in mind depending on if you're targeting specific devices, whether they will honor those permissions from other applications. File connection is really the only suitable choice if you have large files because file connection is the only API that's capable of writing to the SDs in the devices. The persistent object store I talked about before goes straight to flash memory, and you only have about 128 to 256 megabytes there. Sure, I'm getting my notes here. Okay, so SQLite and Blackberry. SQLite, if you haven't heard about before, is basically a file-based SQL database. I'm not going to spend a lot of time talking about SQL injection here, except for folks who are aware of SQL injection issues. There's APIs in Blackberry to make sure that your SQLite queries are parameterized. There are three interesting options that you have for using SQLite databases in Blackberry. When you're creating the database, you can define them as being not encrypted and accessible to any other application, encrypted or still accessible to any other application, or encrypted and only accessible to applications that are signed with the same signature as the application that created it. In the context of the secure wiping situation we talked about before, it's certainly a safer option whether you're making your SQL database accessible to other applications or not to make sure that it's encrypted. And that encryption is tied right down to the device. So in the event that your SQL database needs to be ported to other devices, you're going to have a problem there. So there are a few miscellaneous BlackBerry issues that I thought should be brought up. In general, BlackBerry devices, although less so with current deployments, the expectation that a BlackBerry device is going to be required to go through a BES or BIS. That's BlackBerry Enterprise Server, BlackBerry Internet Server, to get out to the internet. If you're doing any kind of SSL sockets in your application, you may ensure that the connection between the BES and the BIS are encrypted to whatever your endpoint is. But if you don't specify that end-to-end required equals true, then there's a possibility that if the BES or the BIS has assigned a self-signed certificate to your device, there won't be any kind of complaints whatsoever. If your device is receiving a self-signed certificate for the BES or BIS, that's a pretty big red flag security-wise. Another thing is that during the application process for receiving the code signatures to access the crypto APIs, the storage APIs, and the other APIs, all of the signing material once your application is provided, once your application is approved, is emailed right back to you. This can be kind of a concern depending on your corporate email retention policies and the ability for an attacker to sniff that communication or retrieve it at some later date. So you need to take special care making sure that once you have your code signing material available to you, that it's cordoned off somewhere. And just as a minor note, the BlackBerry UI provides a password edit field. You're providing a field where the user is entering a password, and instead of displaying the password back to the user, you want to display bullets to mask what the password is. Just in my testing, it seemed awfully slow. This could be just the fact that I was doing everything in an emulated environment. But a user who sees the password field display characters and then eventually overwrite them with bullets may reduce overall trust by the user in your application to perform securely. So moving on to Android, they've sold about 5 million phones right now, which is very respectable given how long they've been around. Over 70,000 apps in the Android market. Like the BlackBerry applications, they're not required to be available on the market. It's just a good general guideline for what's out there. Android is based on the Davlik VM, which is kind of like a Java VM, except not really. And we'll be talking about those differences later on. And there's also a C++ native developers kit for folks who want to write part of their applications in C++. I won't be discussing that here, but the same general issues when using unmanaged code like C++ exist. The release schedule for Android has been kind of hectic. They've been doing new releases just about every 6 months, but they're aiming for doing yearly releases so that developers don't have to always be playing catch up with the changes that they've been implementing. So no real discussion about the Android platform can move forward without an understanding of what activities and intents mean in the Android context. And I'm not sure that I have enough time to do justice to it. I know there's actually a gentleman who gave a talk here last year that just talked about Android. He did a very good presentation. I encourage you to look at that in the archives. But from a 1,000-foot view, activities are ways for your application to do work on behalf of itself or on behalf of other applications. And those activities are launched using intents that are shared between those activities. So an activity will register itself and say, I'm capable of providing GPS information to applications. Or an activity will register and say, I'm capable of providing photos from the user's library. And then other activities and other applications can send intents to those activities and receive photos or receive GPS information and use them in their own application. So there are a few security issues to keep in mind with the intent mechanism. There are a couple of different intents that can be sent. Explicit intents go directly to the applications that you define. Rather than being registered in any sort of sense, the intent is received and automatically delivered, and it's up to the activity to handle it whether they intended to receive it or not. Implicit intents are even more interesting in the fact that there's no specified destination for it. The Android system looks at the intent, looks at the content of the intent, and looks at the registered activities and says which activity is best set up to handle this intent. And which activity is ever best set up, that's the one that will receive the intent. Skipping back a bit, implicit intents can be filtered. You can define an activity that says, I'm only going to handle intents that look like this, don't send me anything else. Explicit intents can't be filtered in any way. You'll receive their intent and you'll have to handle it, validate it, or discard it as your application requires. As far as the implicit intent resolution, there are a couple of interesting issues that pop up there. First of all, as an attacker, there's nothing to stop me from developing my application and saying my application is the best for doing exactly what your application needs it to do, instead of, say, the native Android components, which don't have any kind of higher authority in the resolution process. The resolution process doesn't say, is there any native component that can handle this? If not, then let's look at the third-party applications. It's blind in that way. So if my application is better registered to handle your intent, then it's going to handle it whether you want me to or not. So you need to be careful with the information that you're sharing with third-party applications in your intents. You also need to be careful to validate the information you're getting back from those intents. As a follow-on issue there, perhaps an application isn't able to register itself as the best to circumvent your application. But it can certainly register itself to be as good as some other component that you're hoping your intent goes to. And what happens in that case is that the user is presented with a pop-up. The Android system says, hey, I found 2 different applications that can handle this intent. Which one do you want me to use? And so now you're trusting the user to make the right decision. And as the third-party application developer, I can try and trick them in any which way I want. I could present my application to display the same name as your application, and they won't really know which one to touch. Also, with the intent situation, since you're not exactly sure where they're going to go to, I could, for example, man in the middle your intent request. I'll take your intent request, just make a note of it, and pass it on explicitly to another component that I know can handle it better. I'll get their response, send their response on to you, and in that way I'll man in the middle your intent activity. So there are a few features in place that can help limit the fallout from that situation. Permissions in Android help you restrict who can call into your code. Applications may send you intents that you don't want to handle. Perhaps you only want to handle intents from other activities in your application or other activities in other applications that you've written, but not activities from other applications that you don't even know about. And so what you can do at the activity level is define an activity to say, here's a unique permission that this activity has. And I'm only going to enter intents from other activities that have this